live streamed events, you'll see me floundering at this moment in time because you never actually know when it's gone live. It kind of just does it partway through, and you look a bit silly, but that's now live on there anyway. So now we are being live streamed to YouTube. Now I'll share my screen. I'll share this just here and share. So thank you very much for coming along to Knots IoT. Before we get going, we do have a code of conduct here. There's a lot of words on that slide, but really what it means is that bottom right-hand corner, be kind and considerate to others. So if everyone's nice, then it'll all be good. And everybody that is here, I'm sure, is nice. So it should be good. If anybody feels like the code of conduct has been broken in any way, then please do drop myself a message in the chat. And I'll make sure that we sort that out because I want everybody to feel comfortable. So do please bear that in mind. Thanks very much to our sponsors for tonight. So JetBrains, they're sponsoring us a product. I'll talk about that in a second. And so are Raspberry Pi this month, which is really cool. And then my company that still runs in the background, even though I work for Avanade now, PJG Creations, that company pays for all of the hosting for the website and for travel and parking and all of those bits. So that's what that's doing on there. I mentioned JetBrains. If you don't know what JetBrains do, they make developer tools for developers. So that's things like Rider, IntelliJ, WebStorm, PHP Storm, ReSharper, all of those type of tools that you may or may not have heard of. And they're giving away a license to only one of those single products for 12 months. So if you tweet on the hashtag NotsIoT during the event tonight, at some point after the event, I'll go through and I'll pick a worldwide winner. You can be anywhere in the world for this, and a person will win a license for a JetBrains product, which is cool. So thank you to them. But also this month, Raspberry Pi have very kindly sent us a brand new Raspberry Pi AI kit, which I'll talk about shortly. And again, if you tweet on the hashtag NotsIoT, then one lucky attendee tonight will win one of those. Now, this is UK only. Sorry to the folks that aren't in the UK. Tax and postage and all of those things are a thing. So unfortunately, this is only open to UK people. Sorry. So if you win on either of those two things, if you're going to be tweeting, make sure you follow Knots IoT because we'll need to send you a DM for you to win. So please do follow us to make that work. So other than that, there's a couple of Microsoft MVPs on this call tonight. Myself, and I know Sander van der Velde is also an IoT MVP like me. So this is a program by Microsoft that rewards folks that run events like this or speak at events like this, like Christophe's doing, or contribute to things like open source or blog around Microsoft products and platforms and services and things like that. So in reward for our time and effort doing that, then they give us access to the product groups, the folks that work at Microsoft to help drive the direction of products. But also they give us a few Azure credits for nothing, which is nice. Free access to Office and Windows and some perks along the way for that. Really, it's the close ties with Microsoft that are the value here and the ability to then be closer to all of the other MVPs, especially in your category. So if that's something that interests you, then by all means, either talk to myself or Sander van der Velde, and we'll be happy to help you on your way with that. So tonight, and shortly, in a few minutes, Christophe Crémon will be talking about Azure IoT Operations, which is going to be really interesting. So I'm looking forward to that. The demo is brilliant. Coming up on Monday, in fact, either on Zoom or if you're around the Nottingham area in person at BGSS, Laura Graham-Brown will be talking about Fabric, which plays a part in tonight's talk as well. So Fabric, what's the fuss about? That's going to be a really cool talk as well. So both Christophe, myself, Dan Benito in the chat here, and Laura Graham-Brown are all Avanades. So we're crowded around in that space, in the Microsoft space. So do check that out if you're around. So that's that one. Now, if I switch across to this one here, we'll talk briefly about the brand new Raspberry Pi AI kit, which is really cool. So this has been enabled by the Raspberry Pi 5, really. A little bit about me. So this is now a little segment of a talk. So I'm an application architect manager at Avanade, as I mentioned, Microsoft certified trainer, an MVP, Pluralsight author, and I've been doing this for as many years as my hair is grey. And I organise meetups like this one and .NET Knots. And I'm also a gadget addict, which is obvious because I like IoT. And I'm also a STEM ambassador because I've got a couple of little girls at home and I want to make sure folks have got access to all of this cool stuff that we take for granted and do every day. So the Raspberry Pi AI kit, and that's kind of what it looks like in its separate two parts. So we've got a Raspberry Pi 5 M2 hat here, and that is connected to the Raspberry Pi using the new PCIe connector. So if you didn't know, the Raspberry Pi 5 has got a PCIe connector for high data transfer between hats, hardware attached on top, and the Raspberry Pi itself. So this is really made possible by that on the Raspberry Pi 5. So Pi 5 only, all of this. On top of this, we've got that M2 form factor section of the board that you saw separately on the previous slide, and that's got this Halo, the manufacturer Halo, and their 8L chip. And this is a neural processing unit that is able to give us 13 tera operations, or TOPS, which is the AI mark of speed and operational ability. And 13 is a pretty good number, to be fair. So this is a pretty powerful piece of kit. What's nice is this all integrates directly with the Raspberry Pi camera as well. So when we've stacked it on top with these supplied headers, we can do some things like object detection, for instance. So we can see, I mean, if you've done any form of like Edge Impulse or other AI frameworks like that, TensorFlow, then you'll have likely seen this sort of thing, but it's going to be the speed that the Raspberry Pi 5 coupled with this board gives you. You can also do pose detection, which you don't see all that often on small boards like this. So it detects the points in your body and draws lines between them, which is quite cool. And again, that's in real time now. So and quite a few frames per second with that as well. Now you can get all of the documentation in this link just here around all of the how you get started with it in that bit.ly. There's a full data sheet which gives you all of the lowdown details, including sizes of boards and everything for manufacturing benefit. And then also, if you want to go buy one, then you can buy one either from the Pi Hut at that link or Pi Moroni. We love both the Pi Hut and Pi Moroni folks, so go show them some love. It's around £60, 60 to £70, so it's not that cheap, but you're buying a really powerful neural processing unit for your Raspberry Pi. And yeah, it's definitely worthwhile doing. So that's about it. If you want to contact me directly, then hit me up on Twitter at Pete_codes. In fact, don't follow that bit.ly. I've not updated that. That's from the slides from the last time I did something like this. But there's not much for you to go get anyway. You can just take a screenshot of that link's just there and you'll go grab everything you need at that point. So I'll now shut up. Do tweet on the hashtag NotsIoT, because you've been with the chance of winning that JetBrains or that AI kit. Well worth doing. I'm going to stop sharing and I'm going to pass the book over to Christophe for him to get going with what he needs to do. In the meantime, while we're doing that swap over, if you could stay on mute during the talk and put your questions in the chat, I'll be keeping a good eye over the chat, and if there's a question there that I can ask at a particular time, I'll interrupt Christophe just so that we don't take him out of his flow of delivering his talk, and then at the end we'll open up the floor and folks can ask their questions then as well. So other than that, enjoy and I'll see you on the other side.
Thank you, Peter. So it's thank you everyone for joining this call. I will start by introducing myself. So my name is Christophe Crémon. I'm responsible of the industrial IoT offerings for Avanade in France, Belgium, and Netherlands. My background is cloud solution architects, specialized in Azure, Microsoft Azure technologies. And my daily tasks, I would say, are to help my customers achieve their industrial transformation in terms of digitalization of the processes. Today, I would like to demonstrate to you what we can achieve in terms of solutions to help customers doing that process, retrieving data from the shop floor, from industrial equipment, such as here, contextualizing this data and being able to put AI on it, and specifically GenAI on it, to have the scenario of talk to your factory. So I will show you this demo. So first, what is the challenge? What are the challenges? We have three challenges when we are talking about industrial transformation. So the first one is we have several sites, physical sites for customers that are working in the manufacturing area. They have many factories in many sites, geographically distributed, and it's very complex to connect all those existing infrastructures and assets across the locations. And on top of that, we have the cybersecurity challenges and the connection to the cloud that may be involved in this process. The number two is the ability to reconcile the information technology and operations technology. Information technology is more what we can call modern workplace, what we know with all the laptops, all we know with office suites, all we know with PowerPoint, Word, Excel, and so on. And operations technology is more on the shop floor itself, the computers that are running near the machines, the equipments. And I would say that it's not the same people that are using it. So it's a challenge to reconcile them. And the last one is to empower businesses and accelerate the adoption of the new digital solutions, and being able to embark the people from OT in these new technologies, so that they are not afraid of, but they are embracing them and using them on a daily basis. So as I said, on the IT side, these are the main profiles you may see: the developers, business analysts, IT pros, and the challenges for them and the main topics are more on security, automation, monitoring, governance. But on the OT side, people are more dedicated to specific tasks in the factories, on the shop floor, and they don't have the same tools. So what is the promise of Microsoft Azure IoT Operations? Is the ability to reconcile these two worlds and these two worlds, sorry, and being able to work seamlessly with the same tools in IT and in OT, and being able also to send the data from the shop floor to the cloud. The shop floor meaning the factory and all the equipments in it. When we want to do that, we see that we have some challenges on the data. We see that the data foundation can be very challenging in what is the equipment talking to us. Basically, receive a message and serial number from a machine. I need to contextualize the data. What does it mean if there is a threshold that has been raised? What do I need to do exactly? So the main challenges we have on the data topic is unifying the data, being able to retrieve all the data from the different factories and all the equipments in it, then contextualize the data, as I said, to be able to understand the physical world that is in the factory, and at the end to democratize the data and being able to share across the group and across the company all the data coming from the factories, so that it's allowing people to play with the data, to analyze, and to add more scenarios on top of the data coming from the shop floor. What's complex is that when you want to do such task, you see that you will have many solutions to connect, basically, from many manufacturers producing machines, equipments, and that you are using in the factories. You will have many proprietary data standards. You will have the high frequency of the data. So you can have machines sending 1,000 messages a second, for example. And you have to handle all this complexity in a system that will facilitate the ingestion, the contextualization, and the sharing of the data. Once the data is stored in the same place, I would say, basically it will sit in the cloud. you will be able to put AI on top of it, and being able to have those key opportunities in terms of what we see for our customers, what we can improve. The main one I would say is more on the quality control, being able to improve the process, the production process, and the quality of the process. So every piece that is manufactured by your equipment will be 100% good, no no quality issues. And I hope it's the same for the Raspberry that Peter will send to you if you win. And the topic number 2 is on the predictive maintenance, to be able to reduce the downtime of the machines, and to be able to optimize the production process. Reducing the downtime will allow you to have the best performance in the process. We see also topics on sustainability, where we want to reduce the waste produced by the machines. So if the machine is not calibrated in the correct way, you will produce waste because you can scrap some parts and you were not supposed to do so. And we see also on the worker efficiency, I would say empowering the workers on the shop floor with the digital tools, and being able to provide them, and specifically with the GenAI part that I will show you, the ability to be expert on the shop floor, but not dependent on several solutions, databases, and so on, that they will need to query to have the answer on their questions. So it gives them the ability to use the natural language processing, or asking questions in a natural language, and having the answers from various systems where they are not able to access it easily in real time. When I said that, I will pose just for you a quick architecture schema on what is I would say the vision of Microsoft. Again, I'm not talking on the behalf of Microsoft or Avanade. I'm just showing you what we are able to deploy such as solutions for our customers. But what we see from Microsoft is that before around 2019, and we'll see with Sander what is his opinion on that, we saw that having edge capabilities was a little bit of a challenge in terms of failover capabilities, where you have only one VM running in your factory, extracting the data from your different asset industrial equipments. Then you send all the data into a cloud gateway that is mainly IoT Hub or Event Hub. And then you have all the process of data processing, data contextualization, and all the MLOps that you can use to train model in the cloud and execute them at the edge. It's now moving into Kubernetes solution. So Azure IoT Operations is no more running on a single VM, but you can run it on a Kubernetes cluster that will allow you to have more resiliency and failover scenarios. Microsoft is now pushing more Microsoft Fabric, that is a SaaS solution. I have some echo I think it's okay. Microsoft Fabric, that is a SaaS solution allowing you to compose with the different activities when you are processing your data, ingestion, processing, and storage. We still have Databricks that is here in the processing part, because we know that some customers love Databricks, and personally, I love Databricks too. And we have new capabilities with Azure OpenAI to be able to play with the data, or to be able to extract insights from the data. So as you have seen, I'm talking a lot of data about data, because at the end of the day, all the machines are sending their telemetry, and we have to handle the load, the flow, and how to contextualize this data. So in this demo, what I will show you is how to apply GenAI on top of a manufacturing company with a custom agent, and I will explain what are the different tools or bricks used in this demo. But first, about the scenario, so I created a fictitious company called Lightning Cars because we are building, manufacturing electrical cars. We have 4 factories, one in Germany, 2 in Germany, 1 in USA, and 1 in China. Sorry, it's 1 in Germany, 2 in USA, 1 in China. You will see the slide after this one. And we are manufacturing different products, cars, trucks, and batteries. And what's very important here is even if there is a lot of standards in industrial IoT, so that's sometimes you are lost because there are too much standards. There is one that is very interesting, is the ISA 95 that allows you to describe the hierarchy of the equipment in your factory using this standard. So you will start with the enterprise, the site, physical, geographical, the area, the line, and the cell. So I will show you in the next slide what it means. And for this demo, I'm using a simulator to generate the data because obviously I don't have 4 factories in my office. And the telemetry data is sent from every cell every second in a JSON format. So big picture here, as I said, 4 factories, 1 in Germany, 2 in USA, 1 in China. Each factory is composed of area, line, and cells. So the cell here would be, if you are in the manufacturing world, can be a conveyor or a press doing the manufacturing process in your factory. And the products, as you see, we have different cars, a truck, and we are also manufacturing batteries. What are the tools we use, are the blocks, as I said. So first I will demonstrate Azure IoT Operations. What is useful in Azure IoT Operations is that it's a simplified way of ingesting the data from the shop floor, contextualizing it, normalizing it, and reduce the load between the edge and the cloud so that you will send only the data you want and reduce basically the payload and only the tags you want in the message. A tags mean a key and value pair where you have the value of the telemetry coming from the equipment. Important point is that Azure IoT Operations is running, as I said, on a Kubernetes cluster, and this Kubernetes cluster is enabled with Azure Arc. Azure Arc acting as an agent that you install on the cluster, and this agent will be able to unroll the Kubernetes cluster in Azure in the portal, and so that you will see that your resource that is not Azure native will become as Azure native, and you will be able to control it and to understand what is running on your cluster. Then we'll use Microsoft Fabric to push all the data coming from the factories and to contextualize them, to enrich the data if we need to have some enrichment with reference data sets that can be at the edge, in the cloud, or both. And finally, we'll have the factory agent that I will show you to be able to talk to your factory, ask questions based on the data stored in Fabric, and have answers to your questions. So for Fabric, about Fabric, we have those components that I use in the demo. So one lake is, I would say, the new data lake for Microsoft Fabric, where all the data sits in the one lake. We have the Synapse time real-time analytics that is now called real-time intelligence module that we will use in Fabric to allow real-time scenarios. So for that, we'll have several components that we will use. So the event stream that is used to ingest the data from the edge to the cloud. Then we'll have the Kusto Database to basically materialize the data from flat files, JSON files, as I said, from the shop floor into tables so that you can query the tables. We'll have the real-time dashboards. So we'll have the ability to see the data flowing in real time in Fabric. And we have also Power BI when we want to use reports and dashboards. As we all know that Power BI in real time is not very convenient. So that's why we have the two capabilities. In terms of components, it's a busy slide, I know, but what's important here is that we'll use this rectangle here, that is Azure IoT Operations, again, powered and not powered, but connected to Azure with Azure Arc. And in Azure IoT Operations, we have several components that are very interesting. So the first one is the MQTT broker, and the MQTT broker is a message broker being able to use publish and subscribe mechanism. So let's say you publish to an alert topic, and you will have an application subscribing to this alert topic, and will take care of sending a message or a Teams SMS, for example. And we'll have also the data processor to be able to play, I would say, or process the data in real time at edge and working without internet connectivity. So we can work offline here on the data processor part to be able to contextualize the data that you receive from your equipment. In this demo, I'm using the white blocks here. So a data simulator, as I said, sending data to a MQTT broker. I could have used OPC UA broker and OPC UA server, but it was more convenient for me to use this simulator and sending data directly to the MQTT broker. But the two scenarios are working as well. And then from the data processor, we'll use northbound cloud connectors to send the data in Azure to an event hub or to Fabric, depending on the use case. And then we will be able to explore the data with Power BI. Finally, a slide on the data itself, on the data processing part. What we want to achieve is basically to what I call refining the data from the raw data that is coming from my equipment, where the context is not very easy to understand. I'm just receiving the raw data from all the machines. I will use the data processor to create the silver data. So the silver data is refined data, normalized data. For example, the time zone can be adjusted to a UTC 0 so that all your messages are on the same time zone. You want to reduce some verbosity of the original message. So you will be able to do that in the data processor. And at the same time, in the demo, I'm enriching the messages coming from the industrial equipment and being able to match them, or I would say use join between a database with all the operations data. So the name of the operator that is on the line, on the factory, the shift. I need to know when is the people are shifting or changing shifts. And in the production data set, I will just being able to retrieve the product name based on the machine that is sending me the telemetry. Then I will flatten the message structure. I will show you what it means in reality, and being able also to aggregate the data so that I will send the data in the cloud every minute and not on every message, so that I will reduce also the load from the edge to the cloud. And then finally, when I receive the data aggregated, normalized, and I'm very happy, I'm receiving everything in an event hub. And this event hub will be, I would say, captured by Microsoft Fabric. And using the event stream feature, I'm able to retrieve the data coming from the event hub, sending this data in a Kusto database. That is the technology used by Azure Data Explorer, ADX. And in this database, then I will be able to query the database, but using natural language. I will show you what the GenAI agent will be able to do. And so at the end of the day, in Fabric, I will have the gold data, and the gold data will be the aggregated and enriched with other databases that are only in the cloud. So you can have a scenario where your customer is using SAP in the cloud or other systems, ERP systems in the cloud. And then you will have to enrich the data and contextualize it using more data that was not present at the beginning of this scenario in the factory. And for example, to have the ability to have the maintenance date, maintenance status of the machines that are on another system, not specifically in the factory. And also to have, for example, the operator phone, the operator email address that are mainly in the cloud and not in each factory. So it's the idea here to show you the best of the two worlds, I would say, being able to process a lot of data at the edge, but at the same time, enrich data at the edge with reference datasets, and then complete it with reference datasets in the cloud and having the gold database in the cloud. So when I say that, you will see that from the left to the right, data processing means that I will have what we can call bronze to silver. I showed in the previous slide, where the structure here is not very convenient to read. So the idea to use, when we use the data processor that I will show you, is to flatten the data structure, if I can say in English, and to enrich it with the records that were not here at the beginning, at the message, when the message was received, with reference data sets. And for example, the name of the operator, the shift of the operator, the product that they are building or manufacturing today. And also using the ISA95 hierarchy, all those messages are sent to a topic, and using the topic, I'm able to decompose, I would say, the enterprise, site, area, line, cell in the message, so that I know that this specific message I'm receiving is coming from a machine in Buffalo producing truck model 1, where the operator is Jane, the machine is on line 1, and the area is welding. So I have all the information at the same time in the message, and that's the goal of Azure IoT Operations and the data processor part. So I hope I'm not too fast in my demo, in my presentation, but I will go to the demo to give you a little bit of time to ingest all what I'm saying. So I will start with this one. So basically, my Kubernetes cluster is in Azure, connected to, no, it's not in Azure. It's connected to Azure using the Azure Arc agent I've shown you previously. So I know the status of my cluster. I know what are the extensions running on it. So basically, if you are familiar with the Kubernetes world, it's the pods.
Christophe,
Yeah.
do you mind zooming in just a little touch, please?
Yeah. Boop. Is it better?
Yeah, that's better. Thank you.
Okay. And once I know the pods running on the cluster, I'm also able to know what's the version of each pod, what's the status of the deployment. And the idea here is for an IT guy or someone that knows AKS, that is the cloud version of Kubernetes, so the Azure Kubernetes services that you will deploy in the cloud, for him to have the ability to see the cluster running at the edge in a factory the same way he's seeing his resources in the cloud, so that it's allowing him to know if they have to patch the version of Kubernetes, if the version is up to date or not. If the machine is up and running, you can have the monitoring capabilities with the metrics coming from the Azure Arc agent, and so on. So you will see your resource as a native Azure resource, but it's a physical cluster running in a factory here and not an Azure resource per se. So once I said that, I will show you the part where I use the Azure IoT Operation data processor. So if I zoom too much, I think, yeah, is it better like this?
Yeah, maybe one more step even. Yeah, that's
This?
better. Yeah, that's going to
Okay,
be better.
perfect.
Excellent. Thank you.
So here, what I show you is that I am receiving data, as I said, from different factories. So I'm subscribing to a topic that is basically QTT topic here with my company, Lightning Cars. I will transform the message. So here is a little bit of code, I would say, in a jQuery to extract the payload, to extract the entities of the payload, the values, and adding the metadata in a message. So this is 18 lines. It's not big. You just have to understand how GQ is working. But basically, you will explode the payload, extract the key, the values, and then being able to have a better structure when you use this step in the pipeline. Then I will enrich the message with a production dataset. So what are the products I am producing with this machine? So I have a production dataset that is already running on Azure IoT Operations, and I will map the information with the cell, so the equipment, sending the data with what I have in the database. And it's the same process for the operations. But for here, I will just match on the shift to know what is the shift of this operator, because as you may know, operators are not running and working 24 hours a day, so they have shifts, basically 3 or 4 shifts a day. So I need to know when the shift is changing with the operator working on the machine, so that if there is an issue, I need to know who to contact in the factory. And finally, this one is the merging of all the previous steps. So I have the payloads with the original data, the metadata, the tags, operation data, production data, and I will merge everything and then have a flat view of my message. And at the end of the day, the idea is, once everything is okay, I will send the message to another topic, not the same, obviously. That is to differentiate the original one to the one where the data has been processed. What is the level of refinement of the data? So silver here as an example, and the real time to explain that in this topic, all the data is coming in real time against the aggregated one where the data is aggregated every minute. And so finally, in the aggregated version, I have taking the data from the real-time topic, aggregating it every minute. So just extracting the values from the payload I want to use, and then pushing the information in another topic. So from real-time to aggregated, so that I know as an operator what is the data coming in this MQTT broker.
Christophe?
Yes.
Sander's asking, what kind of data set is it running? Is this a database table of some sort?
Yeah. So in the background, there are data sets in Azure IoT Operations. I don't know the technology that they are using, to be honest. I just know that I'm able to provision them. But what I'm doing to ingest data in those data sets is I've created another data pipeline to refresh the data in the data set using a web service. So I have a web service that is running, generating data and ingesting this data in my data set. I suppose it's almost a SQL database, but at this point, I don't have a clue, honestly, Sander, on what is the technology behind. And last point, in terms of what you are able to do in terms of data pipelines, when you are creating one, I just want to show you what are the different sources, intermediary stages, and destinations. So you can have a HTTP endpoint as a source, or InfluxDB, or MQ broker, MQ topic, as I shown you. And you can have also a SQL server. So you can start with querying a SQL server, and from there, enriching the data, aggregate, call another service, HTTP1, gRPC1, transform the data, filtering only what you want in the message, and so on. And you can, at the end, send the data in different destinations that will evolve. I have to mention that Azure IoT Operations is in public preview. and the version today is 0.5.1. So we are not at version 1.0. So I suppose that more features will come in the near future from now on to the next Microsoft Ignite in November. But today we have such destinations, so where we can push the data away from the edge if we want, in an Azure Blob Storage, Data Explorer, or Fabric, or on other services running in the factory. If we want to call an HTTP endpoint that is sitting next to my Azure IoT Operations, we can do so. Or we can also, as I said previously, store data in the reference dataset to be able to refresh the dataset on a daily basis or every 15 minutes if you want. Do you have other questions in the chat, Peter, or can I continue?
No, yep, far away. No
Okay.
questions.
I hope I'm not talking too fast with all those technical stuff.
No, all good.
So then once we have the data that I was showing you here, the idea also is to send the data in Fabric. You can use other systems if you want, of course, but since it's the push from Microsoft to use more and more Fabric in the future, what I will show you here is how do we send the data from Azure to not from Azure, from the edge to Fabric. So as you may recall, I was showing you in the previous slide here that I am using an event hub to ingest all the data coming from my edge solution, and the event hub is capture, or the event strip is reading data from the event hub to being able to send the data to a Kusto Database. So what you will see in this portal is exactly here, the event hub here, the process of capturing the data, if I can say, what are the tags you want, what are the columns, and so on. So here you see the different columns I have in my JSON file. And at the end, all the data will sit in a Kusto database. So the result of the Kusto database is this one. So I have the silver aggregated. So the same as the one I was showing you, but in a tabular way, or it's a table. So if I show you this, you will see that I have all the columns here from the area, the cell, energy, enterprise, all the information that are coming from my factory, but in a more convenient way than parsing all the JSON files received from my factory. What I forgot to show you is the velocity of messages I'm receiving in the MQTT broker against what I can see in the database. So you will see that it's not really easy to do this humanly without automating the process of data ingestion and data processing. So you can see here in my simulation, I am simulating one factory in particular in Germany, in Berlin. I can see then that I have several lines for each area. And for each line, I will have an equipment that we can call a cell in the ISA 95 standard that will send the energy, humidity, cycle time of the machine, the pressure, the quality status, the speed, and so on. And the idea is, as I've shown you in the different topics previously, I will reduce this from a message that is not easy to read, to be honest, to a message in the process data topic and in the silver and aggregated, as I was showing you, to have a structured way to see the data in a flat hierarchy, if I can say, with all the data coming from the different machines. I choose to have only one operator in this factory. I know that in reality you have many ones, so it's normal to see this. But you see that Berlin is manufacturing the car product one, and this is exactly what I was showing in this in the slide. Where is my? Yes, in the slide here, the mapping I was showing you is this equipment in this line, in this area from the Berlin site, producing this car model 1 as the example. So again, coming back from the MQTT broker to the sending the data to the cloud and then ingest in Fabric, what it will allow me as scenarios is once my data is in my database, in the silver aggregated one, I'm also able to enrich the data using other reference data sets that can be in the cloud at the end. And this is why here I've chosen to ingest data for the maintenance, to have the maintenance date, serial number, maintenance status that was not present in the original message. And the same for the operator, the ability to have the phone and the email that was not present in the original message coming from my factory. And all that will be executed using a function. So the function will enrich the data with the reference data, and it's basically a join between the equipment ID that I'm receiving and what is present in my reference data set. And if there is a match, I will be able to enrich the data, and send it in the golden database. And this time the gold database is handling all the data from the factories with all the different enrichments at the edge in the cloud from my different sites. And this is where I'm able to have rich scenarios with the GenAI copilot I created. So if everyone is not sick and is still following, you are still following?
They are. And in fact, Sander's got another question. He's asking where the MQTT Explorer is running. Is that in your local network next to the edge device?
Yes, exactly. Yeah. It's in my living room, to be honest, on an Intel NUC. I have an Intel NUC, and then I can show you also what are running in terms of pods in my Intel NUC. You will see that I have several pods that are running, and each one is responsible of a specific component in Azure IoT Operations. So for example, the DP ones are for the data processor, and the MQ ones are for the MQTT. So I'm able to know in terms of what I am receiving in terms of messages. I'm able to debug in my Kubernetes cluster if I want to see the log here. And the bridge I created, and don't worry about the crash look back off on this one. It's a buggy version. So as I said, it's version 0.5.1. So they will fix it soon at Microsoft.
Yeah, I see that same problem. Yeah, there's some fix for that.
It's
there's some docs,
restarting, but it's not blocking the demo. So hopefully,
it's all good.
and what I created on top of Azure IoT Operations is the bridge to Event Hub. So here is the ability for me to send the data to a Kafka Event Hub or to a Kafka topic, Apache Kafka, if you know the technology, and so that all the messages sent to my local MQTT broker are sent to my Event Hub, that is my distant or cloud broker, MQTT broker, if I can say, to simplify the process, and so that I know that every message is sent from the edge to the cloud. And for the simulator, and for the sake of this demo, the simulator is running on the same cluster. For sure, it will not be the case in a factory. It will not be a simulator. It will be a real OPC UA server sending the data, but it's here for the sake of the demo.
Just quickly, C-Sport has asked, in the case of connection issues between Edge and the cloud, will the messages be resent or are they just lost?
Can you repeat, please?
In the case of connection issues, so if the internet goes down, are messages resent later or are they just lost?
Yes, yeah, they will be resent later. Today, there is no mechanism to configure the retention. I've not seen that in the configuration part of Azure IoT Operations. But what I've seen is when I tested this scenario, if the connectivity is lost, you will continue to stack the messages on the local MQTT broker. And then when the connectivity is up to Azure, all the data will be sent. So, and using the good timestamps, because if the timestamp is not good, you will have a lot of issues. So yeah, but I don't know exactly. There is no technical documentation on this. on the retention time if you want to delete all the messages that will not be able to be sent in more than 1 hour, for example. But maybe they will improve this, and it's a good question. Thank you for that. So what I was showing you is my data is here, I'm happy, but let's say you are an operator in the factory and you are not very good in Kusto query language. You know, it's not very easy to find what you want in the database if you don't know the language. You can have for sure the IDE, and you can have the help here when you want to make your query. But if you have to resolve a simple question, who is the operator working on this site? What is the shift of this operator? What is the maintenance status of the specific equipment? You will have to query everything by yourself, and this is not very easy if you don't know the language. So I know the language, I can show you an example, but it's not really easy to do it. So I would just, as an example, I want only the maintenance status of this equipment. I need to understand the query and use the specific keywords to be able to have the result. So for sure, I have many records, so that's why I'm receiving this. So as you see, the problem sits between the chair and the keyboard. But anyway, but what I wanted to do with the scenario of the Copilot is to be able to simplify the process instead of writing the query by myself, to ask GPT-4o to do it for me, and then to retrieve the data and to display the data in a convenient way in a web interface. So for that, what I used is the semantic kernel. So the semantic kernel is the way to map a code that is a Python, C#. I don't know if Java is supported yet, but maybe. And map this language with a call to an OpenAI or to a LLM API, basically. It can be also models from Hugging Face with Mistral, Llama, and so on. But the semantic kernel will simplify the process of taking care of the prompt from the user, the code that is running in the backend. Let's say you have the code, as my example in Python, querying data from a Kusto database, mixing the code from the Python and the API from the LLM model you want to reach. So for that, what I used is Azure OpenAI. So Azure OpenAI is, I would say, an enterprise version of the OpenAI and ChatGPT specifically that we use in as a public or consumer way. And it will allow me to create deployments. So the ability to deploy a model for me with specific rules and to access it from my enterprise user, so that I know that all the data that is sent to this specific deployment, specific GPT-4o model and for my enterprise, will be stored in a secured way in an Azure storage that is for my company. And so it will not be used to retrain the model publicly on ChatGPT, so that I'm sure that if I have a lot of secrets and I don't want to share them, I'm sure that they will not at the end train the public version of OpenAI ChatGPT. It will sit in my Azure landing zone, Azure storage, and everything will be monitored here. If I want to know in terms of risk, safety, moderation, I can adapt the model for me as I want to do it in an enterprise scenario. And from there, once the model is deployed, I'm able to call the model. So I will give you an example. I have the prompt of my user that wants to know the list of operators working in the factory, and what is the shift associated to each operator. So the factory agent that is using the semantic kernel I was mentioning will analyze the prompt and write the query. So using GPT-4o, I will be able to write the right query. So this is an example with the name of the Kusto table. Write what I need to retrieve in terms of columns, use the distinct operator, and then execute the query in the Kusto database and retrieve results. And then, as a user, I can have this seamless solution. So I will show you the demo, and I hope that the god of the demo is with me tonight. So this is the live demo, and I will show you in background what is happening also when I'm running this demo in terms of the query that will be executed in backend. So I've already executed some queries here. What I will do is I will shut down the demo, restart it from fresh. So
Might want to zoom in on both of those bits. Sorry.
I hope that the Streamlit version and the Python code will run after this column after this command. What I have to add is the backend is in Python, and I'm using Streamlit for the web interface. It will allow me and facilitate the development at the end. So I'm starting it again, just waiting for it to be ready. In the background, what it will do is obtaining the schema of the table I want to query, because I don't want the user to give the schema of my table. Otherwise, it's not it's useless. So that it will discover and it meaning GPT-4o will know all the columns and the type in that time, integer, string, and so on. And so when I will run my question, and I hope the god of demo is here with me, I'm able to have the results as you see here. And in the backend, I have the query that was executed. So I know that this query, for example, if I copy paste in my database that is here, and I use the exact same query, I should have the exact same results as what was present in my demo. For sure, you can have more complex scenarios where you want to calculate, for example, I want to calculate the yield for each site. So I want to know what are the good parts, bad parts that were produced on each site. And it's not easy to calculate, to be honest. And you see that in some seconds, you have the results. You know that the best factory or having the best quality, and it's very intentional here that in the demo, I set some in the simulator anomalies. Otherwise, it was 100%. It was not funny. And you will see that in the backend, the query for that is very high to do it by yourself. So you see that GPT-4o here was able to write for me this big query to understand my context, what I want to do, what I want to calculate, and for an operator to know exactly where I have the more issues in my all my factories. I know that here, for example, Shanghai is the worst in this specific demo right now, but maybe in 2 hours it will be best. And the last example I wanted to show you is more on the human ability to talk to a human or to debug a situation where there is an equipment that is down in the factory. I need to contact the operator named Tom at the site of Austin. So I will just show you why I said Tom. I will first give a list of operators, the sites they are associated with, and the current shift. So waiting for the result here. So the god of the demo is not with me here, but I will just restart. Sometimes, you know, the hallucinations from GPT-4o as a kind of hard to handle. So that's why you need to give it a new try. And this is working now. So I see that Tom is on Austin site and on shift number 2. And if I want to have the phone of a number and the phone of operator Tom and the email address, I can have the result really easily. So to conclude, what it allows this in terms of scenarios is an operator in a factory without this kind of tool, we'll have to use several databases, several applications, several maybe data sets, and maybe to cross the columns that are not the same name of columns in the different databases, mainly using the beautiful Microsoft Excel, using pivot tables and so on. And here, the idea is to contextualize the data, send the data in a single place, so in Fabric, as I said, to materialize the data in a table using the Kusto database I was showing, and then being able to create the data, and it can be from different databases, different tables, but here it's only one for the demo, and for the operator to be aware to be able to have the answer very quickly and not without the need to ask for colleagues to have extracts from reports from different solutions to have all those informations. So the idea is really to cross different data from different solutions, can be ERP, MES, can be from the PLC itself. And then you are able to have a quick answer on your question. You abstract, I would say, the complexity of querying the database and finding what you want to achieve. The last part is on the visualization, and then I will be done for this demo. So for the visualization, we have different scenarios we can achieve. We love Grafana, to be honest, because Grafana is really easy to configure, easy to deploy. We see many customers using it because mainly because Power BI cannot run at edge. You know that Power BI run only in the cloud. So if we want a scenario where we need a visualization at the edge, we can use Grafana. For sure, Grafana works also in the cloud. So you can also have a managed instance of Grafana in Azure if you want. But here in this scenario, I've just shown you the three different versions or flavors or capabilities when you want to visualize the data. And here you see that you can see the data at edge in real time from Grafana. Here in Fabric with the real-time dashboard I was mentioning at the beginning, and here in Power BI, and to be able to compare or to see the data in different solutions, depending on what you want. What's important here is that the data source is the same, so you are aligned. You don't have one data source per visualization solution, and it allows you to have the real-time visibility at the edge when you want a low latency, less than 1 second, for example. Here it's almost 1 second, to be honest. And for Power BI, it's more on a scenario where you want the data to be refreshed every minute at the maximum. You don't want the data to be really pushing Power BI to the to the limit. So that's why the three scenarios are available for our different clients. So that's it. A lot of technical details in the solutions. A quick recap and the final one on what we achieved what in the demo here. So again, showing you this one. So we were able to extract the data coming from different industrial equipments, contextualize, normalize the data using a connected version of Kubernetes connected to the cloud using Azure Arc with a resource or a server that was not Azure native. My Intel NUC in my living room is not an Azure resource, but I see it as an Azure resource. And then sending the data in Fabric to be able to contextualize and store all the data, because if you have several factories, you want to have a unique data lake at the end that is called one lake in Fabric. And finally, we have the factory agent that is able to query this data, ask questions on the behalf of the user, and write the appropriate queries and show the results to the end user. That's it. If you have any question, let me know.
That was really good. Thank you very much. That's a really cool demo.
Thank you.
because it's end to end, and you've actually presented a solution that people can use, which is what I like, and putting OpenAI on the end of that and actually taking those insights and democratizing them to anybody at any layer, any level is super useful. And so I can see that working for sure. I need to go dig out. I've got an Intel NUC hanging around here somewhere. I don't know what spec it is. I need to find out how Sander got on installing IoT operations on his actual constrained device. He was installing it on something really small. I can't quite remember the specs, but it was below what you're supposed to have been able to install it on. So I don't know how he got on. But
The one I have is an old one, to be honest. It's
okay,
Intel NUC with Intel E5. I think it was Skylake at the time,
okay.
back in 2018 maybe. But I pushed it with 32 gigs of RAM and 1 tera of SSD. But for sure, you don't need too much too much of that to make it running. I think the minimal requirements are I think Intel i5 and 16 gigs of RAM and 30 gigs of storage.
Mm, yeah,
Because at the end of the day, you will not store all the data at the edge for a long period. You will
no,
send it in the cloud. So yeah.
yeah. And for the most part, it's probably just going to be text data if you are going to store it, unless you're doing video analysis, but that's a different job entirely.
Yeah.
Probably not get away with doing that on our tiny little nooks.
It depends because you have some scenarios with video analytics where we are analyzing real-time flow,
Yeah.
video flow. We are training the model in the cloud, but executing at the edge. So the model is very effective, and this is really interesting what you have shown with the Raspberry Pi and
Mm.
you called it the AI hat. Is it right?
Say that
AI
again?
AI hat is the name of the
Yes. Yeah.
Raspberry. Yeah,
Yeah. AI kit, I think they call it, but it's
AI
a
kit.
hat.
Ah, okay.
It's a hat.
So yeah,
Yeah.
should be interesting to do the same demo with the Raspberry Pi 5 and AI kit to see if we can improve the scenarios, because in
Mm.
terms of capabilities, what Microsoft is it's pushing, if I can say, is the ability to connect other kind of devices, and this is where there is a project in the CNCF Foundation, you know, the one that was able to open source Kubernetes.
Mm-hmm.
There is a project called ACRI, and ACRI gives you the ability to bring your own connector and, for example, have live devices that are not using the standard industrial protocols such as OPC UA or MQTT.
Yeah.
And from there, you can, for example, have I think it's the name is OpenVIF,
Yeah. On Viv.
OpenVIF,
Yeah.
uh,
On Viv. Yeah.
on VIF protocol to gather the video and
Yeah.
to only send the message when there is an alert. Of course, you will not send the full video. You will only send the message when there is an issue, for example.
Yeah. It'll be good. I mean, we need a bigger, beefier Pi so we can run this on a Pi. Sorry, Sander, but me personally, because I can't afford the £1,000 it costs to buy an industrial PC.
Yeah.
But yeah, it'll be interesting, certainly. What's your experience in connecting actual, because you're using simulators at the minute, but what's your experience of connecting actual devices to this at the minute? Is it as straightforward as it seems, or is there any gotchas or
Uh, it's not that easy, to be honest.
okay.
The first step is when I'm talking about PLCs, I'm referring to a programmable logic controller. So you have a machine that is, let's say, a conveyor, and the PLC would be the ability to configure the speed or shut down or start stop the conveyor. So the
Yeah.
PLC is, I would say, abstracting. It's an electronic device. What we see in the factories for our clients is all the PLCs are connected to OPC UA server, and the OPC UA server are abstracting the complexity of the cables, the protocols, and so on that you need a specific, not a USB, but a specific cable to get the data from the machine.
Yeah.
So the OPC UA server will be the first server we will connect to. This OPC UA server or many OPC UA servers, if the factory is big, will ingest all the data from all the PLCs. Can be Allen Bradley, Rockwell Automation, depending on the machines, because it's industrial machines, obviously.
Yep.
So we connect to the OPC UA server with Azure IoT Operations, and we can use a username, password, or a certificate. And once we are connected, it's the first challenge because we are not on the same network layer. We are not on the same layer in terms of network connectivity with the PLCs and with the OPC UA. So we have to use different VLANs and protect also the network flows and allow in the firewalls and so on the communications between the two. But once the Azure IoT Operations is connected to OPC UA and receiving the data, it's a huge step forward, I can say. Then you have to handle the part with the cloud. So how to send the data from the edge to the cloud and secure it. You don't want someone to hack your edge solution. So that's why I think Kubernetes is a good idea to use Kubernetes on top of a Linux machine that you can harden if you want using a specific OS. And then you have all the scenarios I've shown in the cloud part where you don't have the connectivity issues. It's a more straightforward process.
Yeah, it sounds good. I'm gonna have a go. I was saying on the call before folks arrived, I've got a Meadow F7 here, a Wilderness Labs Meadow that runs a full fat .NET, and also Jose Samoes's .NET Nano framework for ESP32. So I'd like to have those connected to IoT operations and see real data going through to a real device. And doing that, simulations are great and work really well for an example like this. But obviously, the next step is to try it with real devices. So it'll be interesting to see where I can get to. There's some options for that. Plain old MQTT, I guess, is one way to do it, isn't it? Rather than OPC UA.
Yeah, and the last point I didn't mention, I will just share this quickly with you, is this one. Let me know if you see my screen.
Yep, we see that.
It's at the end here. You can see I put an industrial data simulator, but it's what we call user workloads. So if you want to put a Grafana, IVMQ, MQTT broker, all the containerized applications you want, you can enrich Azure IoT Operations with it. So that if you want only to send the data locally, again, it's inside your cluster, obviously. It's inside your Kubernetes cluster, but it's running apart from Azure IoT Operations, but in the same cluster. It's exactly what I was able to show here in this example, where the IoT simulator here is what we can call the user custom workloads. If you have a specific user application, for example, if I want to use the factory agent with the GenAI I was showing and containerize it, I can also execute it here. It was not very useful, to be honest, because at the end, it's calling a service that is in the cloud in Azure OpenAI. So that's why I not chosen to containerize it, but I would be able, for example, to containerize a Grafana and put it here and have the real-time view in next to my Azure IoT Operations. So all the things that you cannot do here, you can use other components or other containers on your Kubernetes cluster to enrich your solution as you want.
Very good.
InfluxDB is an example. If you want to have your own InfluxDB or the SQL Edge DB, I don't know if it's still live, but the one from Microsoft where you are able to have SQL database at the edge, you can also instantiate it as a user workload and use it aside from Azure IoT Operation.
Very good. I like it. Is there any more questions from anybody else? Silence in the room. As Christophe says, this is all preview stuff, so this is changing all the time. Even what Christophe sees, Christophe, you're working with the product teams. We can't talk about a lot of the stuff that we know is coming down the pipeline. So,
Mm,
just like Christophe, we kind of feel a little bit gagged, but we know that there's stuff happening all the time. They're actively developing this, and this is the way forward for them. Nothing that is out there is going away, though. It's in maintenance mode, essentially. It's feature complete, as the way that they explain it. So IoT Hub and IoT Edge, they're all still there, still going to be supported into the future. So don't worry about that disappearing.
mhm.
Um, but we're in a funny period because they've stopped developing on those applications, and we're not quite ready for IoT operations. It feels like when they retired the space shuttle and there wasn't an actual ready replacement yet. There was just stuff that they're telling you can't use in production. So it does feel like we're in a funny spot right now.
Yeah, but there are complementarity, if I can say, between Azure IoT Hub and Azure IoT Operations.
Yeah,
Azure IoT Hub is doing the device management when you have connected devices, such as smart bulbs, for example, that Azure IoT Operations is not able to do. Azure IoT Operations is more for the factories, industrial scenarios.
yeah,
Azure IoT Hub is more onto connecting a real device where you have a direct method. You can act on the code that is running on the device. You will not be able to do it on Azure IoT Operations. So that's why they developed this solution. I think, and it's my personal opinion, but I think that at the end, Azure IoT Operations could be a replacement of Azure IoT Edge only, Azure
yeah,
IoT Edge. But Azure IoT Hub will still be there in the picture, and they will improve it, obviously, with the feedback from customers and integrators such as Savannah. So yeah.
yeah. I agree. I happen to know that there's some work going on in the background for the stuff you've just mentioned that you can't do, like direct methods. I think there's stuff that's happening in the background that's going to allow us to
Yeah,
do that. There's
I
going to be
heard
a
about a bridge to this, but yeah, it depends on the priority of the team at Microsoft developing the. So as you may know, priorities are changing. So
yep,
yeah, we'll see what they are able to do. But for me, if I can simplify this to someone that is not really in the manufacturing area, so. Sorry for the demo because it's very focused on the manufacturing process and intelligent factory, if I can say. I would say that Azure IoT Operations for me is more kind of a landing zone at the edge. You put an edge solution that is packaged, that is running on a Kubernetes cluster, standard one. You are able to access it and understand what is running on from the Azure portal as a native resource. And then you deploy your workloads. You can use for sure your Azure DevOps pipeline because I did not mention another point is that you will be able to have the GitOps. So GitOps is the process of pushing containers on a Kubernetes cluster by committing files in a repo. So let's say you want to upgrade the version of Grafana that is running on your cluster. Instead of connecting to SSH or to kubectl to connect to the Kubernetes cluster, you push the code in a specific branch. Once the pull request is approved, your cluster is reconfiguring, starting the container, and then you are up and running in seconds. So this is very, very convenient. It's very complex to do it in a factory at the edge when you have no connectivity. If you have to do physically in Berlin or Austin or in Shanghai to update the cluster because you don't have SSH session and so on, it's complex. So that's why I think I see this as a landing zone, if I can say, for the edge specifically, with a process of deployment security that is the same as the resources you can deploy in Azure in the cloud.
yeah, very good. Well, if there's no more questions, we'll call it a night there. Thanks so much to Christophe for coming along and giving us that talk. That
You're
was
welcome. Thank you
awesome.
for inviting me in this call. It was very fun to do it.
Oh yeah, you're always welcome. And CS Ward says awesome demo. Thanks a lot as well. So don't forget you've still got time to tweet on that hashtag NotsIoT to win either a JetBrains license if you're worldwide or if you're in the UK, then that AI kit that we've mentioned before. I'll be drawing that out once the kit arrives. I'll probably do something a little bit fun to draw it out. I know at the last in-person Knots IoT we gave away a Raspberry Pi 5 and we had a quiz, so I may end up doing something like that to make it work. But I'll see what is the least complicated way to do it. But other than that, thanks again to Christophe, and we will see you when we have got the next meetup. So cheers, folks.
Thank you. Thanks.
See you later.
Have a good evening. Thanks.
Thanks all. Bye.
Bye.
Thanks for that, Christophe. Appreciate it. Very good.
You're welcome. Thank you for inviting me. It was very, very fun, honestly.
Yeah, it's great. I've been looking forward to this talk for a while now. I mean, obviously I've seen most of it, but to see the whole thing end to end, it was really good. So
Yeah, in terms of flow, do you think you have studied